Cyber Innovations in the Private Sector highlights case studies and the latest industry trends from private vendors. Explore innovative solutions, success stories, and exclusive insights from industry leaders. Stay ahead with the cutting-edge developments driving the industry forward.
Today on CyberSecTV, we speak with Jesus Molina, Global Technical Director at OTIFYD, about the real-world impact of OT cybersecurity.
My name is Jesus Molina. I am Global Director of Technologies with OTIFYD, which is cybersecurity consulting company focused on operational security, on OT. There is one key difference, which is impact. In IT, we're protecting data, and the impact is your data is being stolen or your data is being erased. That's pretty bad. But in OT, the impact is physical. You can have your water not working, or you can have your energy disappearing. So the primal difference between IT and OT is impact. 10 years ago, talking about impact, the primal difference when it comes to connectivity, when it comes to OT, is that the systems have been more exposed. And the end of the cyber attack is, again, the impact. When there was no connectivity, we only had, 10 years ago, cyber attacks that everybody knew. Stuxnet, Trisis, attacks that were well known and well recognized. In the last 4 years, we have hundreds of attacks that has physical consequences. Attacks that impacted your daily life. This is because of the increased connectivity. Systems are more connected. These industrial systems now are easier to be reached by attackers. And then the physical consequences are felt. The first misconception of NIS2 is that it's not a regulation. It is a directive, meaning that every country has to implement NIS2 as they please. They have to follow the directive, but the implementation is different for every country. What means is that there is fragmentation. Every country can implement it, and people are waiting till their country transpose the directive into law, which has created a lot of issues. Now, the other problem is when people try to focus on compliance. Cybersecurity should be the primal focus. Compliance should be the consequence of you creating good cybersecurity. The Cyber Resiliency Act and how it affects us is something that we should have to have in mind, because unlike NIS2, CRA, it is a regulation. And remember a regulation that impacted us in cybersecurity? GDPR. GDPR is everywhere. We have these cookies that you have to click. You have, all these calls that you have to be recorded, and they ask you to review your GDPR. So CRA, the Cyber Resiliency Act, it is a regulation. So it's going to impact every digital device that is sent to Europe. So everything has to comply with the CRA. Now, there is a big debate if CRA is going to help cybersecurity or is going to drag cybersecurity into a lot of checkboxes. I am right now in the feeling that we have too much regulation in this space. And in particular for operational security, it's going to be extremely complex to comply with the CRA. Imagine a train. A train is made with like hundreds of components. Each of these components needs to be compliant with the CRA, meaning that the HVAC system in the train needs to comply with the CRA. The signaling system on the train needs to comply with the CRA, meaning that like vulnerability, for example, evaluation needs to be done with each device. And at the end of the day, it needs to be kept to comply with CRA. There is this thought that in 3 years, it will make us much safer. And that might be the case. For me right now, it's going to be extremely complicated to deploy CRA into OT components. Term security by design means that you need a plan when it comes to cybersecurity. And to be honest, very few people have it. What I believe is that security by design is a term that has been used by many to say like, I have done the proper requirements for this product or for this infrastructure. In truth, what it means is that when you start a project or you start creating a component or you start any kind of cybersecurity issue, in particular for OT, you need to have a plan. And that means that you have to start with a risk assessment. You need to evaluate what components are going to decrease this risk. Is going to understand how you are going to manage the risk once this system is deployed or this system is in use. Who is going to manage the risk? The processes that are going to be affecting cybersecurity. So at the end of the day, this is having a cybersecurity plan in mind when you start doing anything. Companies can build through cyber resiliency and adhering to compliance, but not focusing on compliance. This is the key here. If you focus on compliance, you first may not meet or may meet the requirements today, but you may be struggling to meet the requirements for tomorrow. What you have to do is to have a plan, not a compliance plan, but a cybersecurity plan. And compliance will be the consequence of this. In our company, we have many people asking for compliance. Say, hey, we want to have NIS2 compliance, or we want to have compliance with this specific regulation on my country. This, honestly, is the wrong approach. I understand where they're coming from, but what you should try to understand is what is my gaps in cybersecurity? What is the things I need to improve in order to take down the risk that my site has? And we're talking here, my company works in the most secure sites, like in refineries, in gas pipelines. I mean, you cannot be checking boxes in these sites. What you have to do is, what is proper cybersecurity? What are my risks? Who could be attacking my systems? And then create a well-thought plan on how to address the risk that your site has. Collaboration between IT, OT, academia, and regulators is something that is necessary for cybersecurity. There is no question to this. Now, we need to find venues where this collaboration is correct, or we can take something away from this collaboration. I was a member of EISAC when I was with my previous company, and it was a great location for European energy actors to come together, discuss with the regulators, and between them, what was the proper way to address the risks. Also, recently, the Cyber Informed Engineering, which is a project, I will say, that tries to move the needle of cybersecurity from software-based to more engineering-based. Think when you have a camera, you can either you don't want people to record you, you can either have software antiviruses that prevent that, or you can put a cap on top of your camera. That will prevent people recording you. That's an engineering solution from a cybersecurity problem. Even if your laptop is hacked, you still will not be able to be recorded. This project has been created by researchers, regulators, has gone to different universities, try to add this engineering thinking when it comes to cybersecurity. Can we put a relay instead of doing like software and like anti-intrusion detection systems, antiviruses? Can we just put a relay that will prevent the impact? Is that a better way to do this? So, for example, Cyber Informed Engineering is a place where people have collaborated to create very interesting outputs, and this is what collaboration looks like. Having an idea which is complicated to address, and with the help of everybody, create something that is actionable. IT and AI is a question that everybody has in their minds. And when you go to a conference, it doesn't matter if it's OT conference or cybersecurity for OT conferences or cybersecurity for IT conference, you say AI everywhere. The truth is that for defense, in IDSs, for example, AI has been used for the last 10 years. This is nothing new. AI has been used forever. I mean, the thing people are excited about is generative AI. However, vendors are very smart, and when they say AI inside or something like this in an IDS, what they are basically saying is that they have been using AI forever, and they are kind of jumping in that horse of AI. So you have to be careful when you say, is this AI? But I'm thinking this is not the chatbot or the ChatGPT you are thinking about. What AI is, not generative AI, is, like the AI that has been correlation, etc., that has been used forever. Now, the question is, generative AI can be useful in cybersecurity, and how? And the answer is generative AI is going to be very hard to fit into cybersecurity, in particular in industrial cybersecurity. And I'm telling you why. The reason why it's difficult to fit that inside is because generative AI has hallucination. It's not discipline. It will tell you things that may be or maybe not true. That may work when you create, a picture of a person that you don't care if there is like a problem here, a problem there. It looks pretty good. You cannot do that when it comes to defending pipeline or defending refinery. You need to know that all the problems that refinery has are covered. Generative AI is not going to help you with that. It probably is going to make it more problematic with you because it will give you false positives. It will provide you with like data that is not true. And at the end, you will make the wrong decisions. What it might be helpful is to, if you have a lot of data sources and you want to generate a report and make it easier for the human to understand what is the posture of your refinery, that may be helpful. But let's address that right now. The generative AI we're seeing today is not going to be very helpful in the short term and in the mid-term for cybersecurity in OT. However, it's going to be impactful because of the other side of the pond where the attackers are. This is going to be impactful for them because for them, they can get it wrong 1 time, 2 times, 3 times, 4 times. They can use generative AI to create attacks that are much more consequential than today. And if they fail the 100 times, that will be fine. But when they take it right 1 time, then your refinery will be down. So it's not symmetrical how the generative AI is going to be used by the defenders and the attackers. For the last 10 years, we have had very few attacks with physical consequences. And cybersecurity in OT, we have been in latest conferences, and I hear people being very complacent, meaning that we have had very few attacks that affect operations. We have a lot of attacks that affect IT, stealing data, ransomware. However, operations, we have Jaguar, for example, that was an attack that everybody talked about. Recently in Poland, we have the attackers were able to break several devices in windmills, and that was very impactful. However, people are saying, but there are very few. I think complacency is going to be the main issue we have to fight here, because OT is a little bit like the security you have at the airports. You don't see planes blowing up all the time, right? But if one plane blows up, that's a big deal. That's why we have these long lines in TSA, in the US, because people don't want planes to blow up. You don't want your refinery to blow up by a cyber attack because unlike kinetic attacks, cyber attacks can be distributed in all the world and can be covert and can take months, and they don't trigger the things in kinetic attacks trigger. So OT cybersecurity cannot fall into complacency. And the second is, of course, what we talk about, AI. AI is asymmetrical. The attackers don't need precision, at least in the beginning. They need to get inside. And they can correlate all this information that you have in your refinery, that before it was very complex for them, and say, okay, this PLC, this programmable logical controller that connects to your refinery and is able to switch the pump, this we're going to attack because now we know, because Gen AI has told us that that's the key. Before they could not know that. Now they can have this information much faster, like an engineer. We don't have to hire an oil engineer or a nuclear engineer to understand how your refinery or your nuclear power plant works. And this is something that is going to dramatically change how OT, at the end, we rely a lot of security by obscurity. Very people understand what is inside all these refineries in terms of digital. But now it's going to be much accessible, and that is going to be very problematic for OT. When I was younger and a little bit crazier, I hacked a hotel. I was able to hack a whole hotel. It was a skyscraper using KNX, which is a protocol that is used in buildings. And from my room, I was able to switch on the TVs of 200 rooms. So it was, in Shenzhen, in China, I was able to go there, press a button on all the TVs on this hotel will switch on. That took me 2 days to do from my room. I was able to collect information using tools such as Wireshark. Now I try to replicate this attack using Gen AI, and it took me 2 hours. And I use the same sources. I kept the sources from Wireshark, all these captures of packets flying around the net. And back then I have to go to the internet, see what KNX was, create a Python script that was able to connect with the different things. And with AI, it created a better script in just 2 hours. Which is worse, it told me things that I didn't know, and I still didn't research enough. Which is what you should do. It told me, because I am a security researcher, I'm trying to implement this. It asked me to the thing that I could do is to brick all these devices. That would be much more impactful than changing the TVs. It says, look, KNX has these routers, and these routers are inside the wall, so are very difficult to reach. If you're able to go to all these lamps, means that you can able to go to these routers too. And these routers, if you brick them, then not only they will not be able to switch on the lights, nobody will be able to switch on the lights. People physically will not be able to switch on the lights. And that will be impactful. So that's what you should do. I'm like, okay. And it's true, because then I researched, and 2 years ago, a group did ransomware in a building using exactly that attack. They bricked the building because they didn't pay the ransomware, or they encrypted these KNX routers, and they wanted the ransom, or if not, nobody could switch on the lights of that building. So interesting that happened, and interesting to understand what capabilities of Gen AI has in the cyber attacking in the physical world, in the operational world. Risk and cybersecurity risk in general is difficult to tackle. And in the world of today, Gen AI, everybody believes that they are an expert in everything. And it is getting a little bit confusing for people to understand reality from fiction when it comes to these tools. Consulting firms like mine, which work in a very specific subject, which is operational technologies, consulting. AI can tell you, for example, that you have a high risk and you should deploy a firewall, but they will never tell you things that how to do proper segmentation using data diets, for example. Or will never tell you that your 50 pharmaceutical firms you have need to be harmonized. They will never tell you these things. So it is in fields that are very specific, like industrial cybersecurity, you do need to understand the field with precision. And that's something that you're not going to have in IT firms or with generative AI or tool.